Hi, I'm Mrs. Mitchell from Laconia Christian Academy, and we're going to start talking about chemistry. And we'll talk about it all year long. We're going to start at the beginning, Chapter 1, Section 1, the Introduction to Chemistry. In this section, in this video, we're just going to talk about the scope of chemistry, and you'll need two tools. First is your textbook. Second is your workbook. And if yours says Teacher's Edition, we should talk. Now open your workbook to page 1 and your textbook to page 2. I'll give you a minute. So now, where should we start talking about chemistry? Why, pufferfish, of course. Pufferfish, or fugu, as it's also known, is a great sushi dish, but in case you're not hungry, let's talk about some of the other reasons why it's sort of famous. And maybe you remember the pufferfish from Finding Nemo. He was the scaredy cat in the dentist tank. Well, what they didn't tell you in Finding Nemo was that pufferfish carry a very deadly toxin. The name of the toxin is tetrodotoxin, and you can see a picture of it there below the pufferfish. And it is so deadly that even Captain James Cook in 1774 recorded in his journal that his crew members had caught and eaten some pufferfish, and they didn't feel so good afterwards. They had shortness of breath and sort of paralyzed muscles, so they didn't eat their whole fish. They gave the rest to the pigs, and the pigs died from it because this toxin prevents some sodium molecules from passing through the chemical synapses in your nerves. And if your nerves don't get the message to keep breathing, like for your diaphragm, then your diaphragm stops moving and your lungs stop filling with air. And that leads to another condition commonly known as, well, death. So this is important. Let's figure this out. And some of the things that can be very deadly, like tetrodotoxin, can be harnessed and applied in other ways, like for cancer patients to treat severe pain. So the scope of chemistry is quite vast because of the definition of chemistry. Well, chemistry is all about matter. The things you see in this slide and on page 2 and 3 of your book consist of things that are represented with matter. The skyscraper is made of matter. The lake, the trees, the leaves, they're all made of matter. Anything that has mass and occupies space. We'll get very good at understanding the idea of mass and the idea of space as well. So here is what chemistry is all about. It's the study of the composition of matter and the changes that matter undergoes. So chemistry affects all aspects of life and most natural events because everything is made of matter. And chemistry is, after all, the study of the composition of matter and the changes that matter undergoes. So now, on the page 1 in your workbook, you already have the answer to what is matter? Why? Matter is anything that has mass and takes up space. What is chemistry? Chemistry is the study of the composition of matter and the changes that matter undergoes. So now here's a question. What's wrong with an advertisement for juice drinks that claims the juice is all natural and free of chemicals? Well, it's all made of chemicals. Even if they were derived naturally, you will still find chemicals in your juice. So now we have 5 traditional areas of study in chemistry. Want to try naming some? You turned the page, didn't you? So let's name them in order. Organic chemistry, inorganic chemistry, biochemistry, analytical chemistry, and physical chemistry. Yes, I know that's not quite the same order that they have them in your book. So here are the answers in order for your page 2 table. The first one is physical chemistry, investigating ways to slow down the rusting of steel. Now, the next one you have is developing a better insulin delivery system for diabetics. Yeah, biochemistry. Determining the amount of mercury present in a soil sample. Analytic chemistry. Comparing the hardness of copper and silver. Well, that's inorganic chemistry, and I'll explain the difference between inorganic and organic in just a moment. Detecting a new carbon-based fiber for clothing is organic chemistry. So now let's talk about that distinction. Most chemicals found in organisms contain carbon. You've probably heard of something like, we went to explore another planet and we were searching for carbon-based life forms. Well, there you go. Carbon-based life forms is pretty much everything that you know that is alive. So science can even be boiled down even further. Is it living or is it not living? So the things that are living typically include lots and lots of carbon. Because of the structure of carbon, it's very handy to build things with. So organic chemistry is defined as the study of all chemicals containing carbon. An organic chemist might develop new lightweight plastics for flying discs. What is plastic made of? Carbon, hydrogen, oxygen. How about inorganic chemistry? Well, if organic chemistry was all the stuff with carbon, then inorganic chemistry is everything that doesn't have carbon, like rocks. So an inorganic chemist might develop metal materials that provide strong structural parts for buildings, and that's very important. How about biochemistry? Biochemistry is the study of chemistry as it relates to biology and living things, like muscle contractions, digestion. Why did the pufferfish make these sailors' lungs sort of stop working so well? Also, a biochemist might study how energy is used for the contraction of muscles. Analytical chemistry. Maybe this one's my favorite. A task that would fall into this area of chemistry is measuring the level of carbon dioxide in the atmosphere. Oh no, did I just say carbon dioxide? Wouldn't that be organic chemistry? Well, you have a point there. We'll keep talking about that. An analytical chemist might test the air for the presence of pollutants. And physical chemistry. This talks about how chemical reactions proceed. Like if you have some water and some salt, put them together and you get salt water. How about water with sugar? You get sugar water. Well, which of those reactions can happen faster? What affects the rate of those reactions? This is physical chemistry. Physical chemists might be concerned with the photosynthesis of the trees. So now, as we have already demonstrated, the boundaries between these areas are not so firm. We have some examples there. And so let's talk about pure chemistry versus analytical chemistry. Pure chemistry is sort of chemistry for the joy of chemistry. You're not really concerned with making something new and amazing for people to work with. So applied chemistry is trying to find a solution to a problem. So if you already know what you need and you just need to find a way to make it, then you'll be classified as an applied chemist. So why would you study the pufferfish if you're a biochemist? How about if you're an organic chemist? Well, there you go. Biochemists, we need to know about how the toxin affects humans. Organic chemists might study the composition. So now, here's a little quiz. Which one of these which area of study would you use to determine the components of an unknown liquid? Not biochemistry, okay. Physical chemistry, let's see, that was the reaction rate. sugar and water together. Well, I know what I'm starting with if I'm a physical chemist. Organic chemist. Carbon-based life forms. Not really sounding like it. Analytic chemistry. Oh, yeah. Analytic chemists would be asked, what are the components of an unknown liquid? So, big ideas in chemistry. There are 8 big ideas in chemistry. And now, in your textbook, flip back to the table of contents. In your textbook, not your workbook. Table of contents shows you the names of the chapters, the sections that are in them, and what the big idea is for chemistry. So let's see what these 8 big ideas are. Chemistry as a central science. Yes, central to physics, central to biology, and central to geology and planetary science. Electrons in the structure of atoms, bonding and interactions, reactions. They're the first 4. Here's the next. Kinetic theory, that's the idea of energy. We'll get to that. The mole and not the rodent. The mole and quantifying matter, matter and energy, and carbon chemistry. Carbon chemistry, what do we call that? Organic chemistry. So here we go. Specifically, on the first big idea, chemistry is a central science. It overlaps with all the other sciences, and most of the other scientists have to use some chemistry in their work. Even an astronomer needs to know what those moons and stars and asteroid rings might be made of, because they might be worth exploring. Electrons and the structure of atoms. There you go. Bonding and interactions. Reactions. Those are the first 4 in the middle section on page 2 of your workbook. So let's keep going. What are some of the others? Kinetic theory. Particles of matter are in constant motion. Solid, liquid, gas, they still are all moving around, all of those particles. We'll learn more about the particles as we continue with our study. The mole and quantifying matter. Does anybody know what a mole is when we're in chemistry class? Yes, 6.02 times 10 to the 23rd. It's a really big number. Matter and energy is the second to last big idea in chemistry. And carbon chemistry. I love this. There are about 10 million carbon-containing compounds, with new ones being prepared every day. This is the gas that you put in your gas tank. This is the plastic helmet that you wear when you go skiing. This is the plastic spoon that you asked me for at lunchtime today. So all of these things are carbon compounds, and all of the living things around you are made of carbon. So now, can you explain what's meant by chemistry is the central science? Nice. And the 3 key concepts from this section. Here's your glossary of terms. Matter, chemistry, organic chemistry, inorganic chemistry, biochemistry, analytic chemistry, physical chemistry, pure chemistry, and applied chemistry. So there we go. Now, if you haven't done so already, please read through section 1-1 in your book.